I had a client recently where we built a supply chain model on a GIS map, and one of the cool things was that you could click on the little roads and we could see KPIs on the usage of the roads. We could visualize it as a heat map. We could do all sorts of things with it, and it's a little trick. So I thought, time to share that with the community. So I built this example model that I'm going to take you through now for you to take away, get inspiration from, use it as a baseline. It's quite easy if you have a little bit of an understanding of how AnyLogic works. So let's dig in. And let me use what I preach by exploring a model, a new model, the way you should typically explore new models. Let's first look at the runtime and see what we can do. As usual, this is the GIS map, so you can do the GIS map stuff with it, zoom into it, pan around. But uniquely now, you can actually click on these roads and they kind of highlight. If you look up here, it actually displays information about what I just clicked. The route from Denver to Miami, or this is the route from Denver to City of New York. You can see some KPI traffic, and we have little buttons here like send a truck, which apparently sends a truck from Denver to New York, and the little KPI thing goes up. If I do that again, it keeps growing, and if you look at the road, it gets thicker and thicker and thicker, which is just a visual trick. So how does the model accomplish that? Let's dive in. The way you should typically approach a model is kind of top down. Let's first look what we have from a hierarchy perspective. There are three agent types: main, my route, and truck. Nothing else fancy about this model. So let's start with main and figure out what happens at the start of main. There are no events, no state charts or anything like that. The only thing that happens when main is created is it calls this finit function. And the finit function itself calls two little sub-functions: the sanity check function, which you should always have, which is just some sanity checking, but more importantly, this create routes function with some code that we need to decipher. I gave you a little description down here, but let's dig into it. Now, the only thing hard-coded in this model is the list of GIS points. I pre-created those GIS points on the GIS map as usual. It's like searching for it and turning it into GIS points. And then I'm storing them in this collection. Now, you can create those via code, just like GIS routes and GIS regions, which you shouldn't do hard coding. This is just for the example model. So in this example model, what I'm doing now is I loop through all those city locations and I'm trying to create a route between each of the pairs. So if I've already created one, or I want to create a route between me and myself, that's not possible. If I already created a route between this start point and the end point that I'm looping through, it's also not possible. But if I find a new combination, what I'm now doing is I use the normal AnyLogic API for GIS maps and create a route between the start point and the end point. And I make it bidirectional. So that's another basic assumption in this model, that all my roads are bidirectional. You can change that. So this gives me a GIS route object, and it's being placed on the GIS map. I catch that, and now I create my own little custom my route agent into this empty population of routes. So add underscore pop routes, and I give it three things: the route itself that I've just created, and it wants two more things. It wants the start GIS point and the end GIS point put into this population. So let's dig into this my route agent type. And we can see this is defined by having three parameters: the route itself, the GIS route, where does it start as a GIS point, and where does it go to as a GIS point. And if we now go into the model, we can actually confirm this. When the model starts, we have 6 my route agents in this population. And if we go into those and look at the parameters, they are stored. There is a from Denver, latitude, longitude. There is a to another latitude, longitude, City of New York. So this my route agent knows exactly which route it represents and where it starts from and where it moves to. Now, the definition of those parameters is up to you. The core thing is you need to have one parameter that represents the GIS route. If you later on make interactive GIS points or GIS regions, you need at least one parameter that represents those elements. But the decision by me to have a from and a to parameter is just to conveniently be able to plot things and print things. You might not need them, you might need more. It really depends on your setup. All right, so let's dig deeper. What's happening in the myRoute agent when that is instantiated? Again, no state charts, no events. So the only thing that happens on startup is finit, which calls the sanity check, which is doing some sanity checking, doesn't matter for now. But more importantly, it calls another function, deselect, which is one of those publicly available functions. Everybody can call them. And the deselect function is actually seemingly changing some stuff on my GIS route. So the getRoute function, which is just next to it, all that gives you is the p-route. So you're just accessing the GIS route of this myRoute agent. And we're just changing some visuals there. Set line color, set line width, set line style to some default values. vColor default is a public static constant variable of type color, and I'm defining it to be gray. By default, my roads are going to be gray. And by default, they're going to be 2 pixels wide and have a line style to be dashed. And if we start the model and look at those roads, you can see they're all gray and have a dashed line style. That is because each individual one of them instantiated itself as a myRoute agent and then called the deselect function to set up the style of those GIS routes. And that's it. This is where the model stops in terms of instantiation. This is where we are right now. So now it depends on what we do with the model. And as I've shown you, you can click on little roads. And if you click on it, it changes appearance. Something changes up here. So how does this happen? The click is caught by the GIS-map itself. It has an on-click property. And what we do here is we catch the mouse click X, click Y coordinates, the latitude and longitude of where I actually clicked. And I pass those into a little function getRouteClicked. I want to figure out with this function, did I just click on an actual route agent? So I loop through all the routes that I have, in this example model, the 6 ones. And in each route agent, I want to get the actual GIS route that it represents, and I call the contains function on it, which is quite useful. This is basically checking, hey, did you click on this route? Did you click on this GIS route with your mouse click? And we use the third parameter, a distance offset. This allows you to, let's look at the description of it. Always use code complete. Is the distance tolerance to determine whether you actually clicked it or not. So in other words, you know, if you look at a map of the United States, it's impossible to actually click a real GIS road because it would be so slim. So we give it like a left and right offset that is also okay to be acceptable as being clicked. And in this model, I defined it to be 10,000 meters, so 10 kilometers. So even if I click 10 kilometers up or down of a road, it will still be considered clicked. You can play around with that. So back to our GIS route. We find the route clicked and store it temporarily in this variable. You may not have clicked anything. If that's the case, the function returns null. And if we did not click on anything, what we do is we deselect all routes. So I might have selected a route, but if I click into into nowhere, we actually deselect all routes. So this function loops through each individual myRoute agent and calls the deselect function, which we've just seen. And also it sets this local variable here, the selected route, to be null. So we have another little variable here on main which represents the current selected route. So the user can only ever select one route. If I click on it, it's populated. If I click somewhere else, it is set to null. And if I select this one, this is route number 2, and then click on a different one, be careful, so we do that, it switches over to route number 4. So you can, in this model, only select one route. Again, up to you. You can change this setup. This is just an example model. Now back to clicking on the GIS map. If you actually clicked on a route, we then call this fSelect route function with the route agent that we seemingly just clicked. And again, we loop through all routes. If we find the one that we've just clicked, we call the select function on it and update our route select variable. And the route select function is doing a very similar thing to what the deselect function is doing. It just updates visuals. It changes the color, width, and line style of the actual GIS route, again with some predetermined fixed values. So we select that route and we deselect all other routes. So that's also important. So if this one is selected and I now click on this one, we also want to deselect the previously selected one visually. Now, as a last step, after having done all this in the onClick function of the GIS map, we call this update dashboard function with the route that we've just selected. And all this is doing is going into our little dashboard and updates a couple of those texts to say no route selected, or you just selected a route from somewhere to somewhere else, and what the traffic level is. So it's updating those two text boxes here. Now, what is this traffic thing? This is one other function in the myRoute agent, the get traffic function. What the hell is this doing? This returns the number of incidences that something is stored in this collection of trucks seen. Why is this truck seen? This is just a list of trucks that have visited this route. And if I look into the description, it doesn't really tell me where this is used or where we actually ever touch this. So let me quickly set it to ignore, figure out where this is used. We have already seen it's used in the get traffic, but it's actually added to in this log truck function. When we call log truck, we call this with a specific truck agent and we put it into this collection. So we store which trucks visited this route. And also we change the line width of our animation, apparently. So we're making it thicker. Every time we log a truck visit, we make it thicker. So how do we call this log truck function? This is called in one place and one place only in this model when we click on this send a truck button, which you can only click if you actually selected a route. So if I click into white space, can't click this, but as soon as I selected a route, this is enabled, and if I click it, it takes the only truck that we have in the model. This is another simplification here. I just instantiate one single truck for simplicity. So it takes that one single truck, tells it to jump, so beam instantaneously to the starting position of the selected route, and then move over time slowly to the end position. And this is where we call the log truck function. So as soon as I click this button, the truck is beamed to the start location. So I selected this route. If I click the button, it beamed to the start location, starts moving along, and already counts for this route the KPI and updates it. So we also update the dashboard to make sure that this text is updated accordingly. And that's it. This is how you can play around with this. So if you keep sending this truck again and again, you can see how the line gets thicker and thicker. You can play with other routes, but essentially the main insight here is you can have your own agent types that own GIS routes or GIS points. You could adapt the model to do that, or GIS regions, make them clickable. Check that with the .contains function that works with GIS points and GIS regions as well. and then just change the visuals, change the KPIs, whatever you want to track along the roads, points, or regions. Very, very powerful. I hope this inspires you and you take this forward to build your own cool models. Thanks a lot.